Okay, guys, today we're going to be going through our first lesson of Chapter 4 dealing with climate. So we have this general question of what is climate. So let's talk about the difference between weather and climate. Now, weather is defined as the day-to-day conditions on Earth's atmosphere. So if we want to look at the weather for today, outside right now it is about 80 degrees, it's sunny, okay, it's not raining. No chance of rain today, I don't think. But the climate refers to average conditions over long periods of time that can be defined year after year, forming patterns. Now, the way we can easily distinguish these two is if you look at October 7th, that's today's date. If you look at October 7th, 2019, there's no guarantee that they had the same temperature, that it was also sunny, just as we can say that October 7th, 2021 won't be, or most likely will not be, the same temperature or sunny. It could be, but it doesn't guarantee that it is the same temperature. Now, so climate is very rarely uniform within a region. Okay, so typically we will find microclimates. These are changing or varying environmental conditions over very small distances. So let's talk about what affects climate. Well, solar energy is going to be the primary thing. Now, the main force that shapes our climate is solar energy that comes in from the sun and it strikes Earth's surface. So a couple of things happen to it. So we see right here in this diagram that some of the heat will radiate back into space. Okay, so bounces off the atmosphere right here. Some of it comes down and is then reflected back into space. And the balance of that heat that stays in the biosphere and the heat that's lost will determine Earth's average temperature. Now, it's largely controlled by concentration of three atmospheric gases: CO2, carbon dioxide, methane, and water vapor. Now, that water vapor, that's going to be primarily our clouds that are there. Now, these greenhouse gases function just like the glass in a greenhouse, allowing the visible light to enter, but they trap the heat through the greenhouse effect. Now, we do need to keep some of that heat, but I'm sure if any of you watch the news, you've heard a lot about climate change and an acceleration of the greenhouse effect because we are putting in more CO2 than can be removed. So if greenhouse gas concentrations rise, they trap more heat, causing Earth to warm. We do have direct evidence of this over climatological records. Now, without the greenhouse effect, though, if we were to remove all CO2, methane, and water vapor from the atmosphere, Earth would actually be about 30 degrees Celsius colder than it is right now. So, yes, it's actually about 65 degrees Fahrenheit. So imagine the hottest day in the summertime would only be about 40 degrees Fahrenheit. Okay, so very, very, very cold in comparison. Now, we also need to talk about latitude and solar energy. So to put this simply, the closer you are to the equator, like we see right here, at sea level, the warmer it will be. Now, that is because they receive more direct sunlight throughout the entire year. Now, in fact, they receive so much direct sunlight that they don't really have seasons here. It's pretty much just the same climate year round. Okay. However, if we move away from that into the temperate and polar regions, we see very seasonal changes in the temperate region and in polar regions. We'll talk about those in just a second. Now, because the polar regions receive less intense solar energy, they don't receive as much heat. Now, during the winter in the polar regions, so right now in the North Pole up here, they are getting ready to transition into winter. Now, on the winter solstice, the longest, or excuse me, the least amount of sunlight, it actually will be completely dark. The sun will not rise at all because they are up here slanted away from the sun. So if we look at this, the sun coming in, if you are all the way up here, you're not going to receive any sunlight at all. Now, conversely, in the summertime, during their summer, it will still be very cold, but they will have almost 24 hours of daylight. Okay, so these tropical zones are found between the equator and 23.5 degrees north and south latitude. The temperate zones are found between 23.5 and 66.5. You may sometimes see the temperate zones called the subtropical zones, and then the polar regions are found 66.5 degrees north and south to 90 degrees north and south. Okay, so as Earth revolves around the sun, solar radiation will strike different regions at different angles depending upon the time of year. So right here, okay, if the sun is over here, that means that it is winter in the northern hemisphere and summer in the southern hemisphere. Okay, so this is what it would be like on winter solstice that is coming up in December. Okay, so we also have winds and ocean currents that transfer a lot of heat. So this is Earth. Earth has winds because warm air is less dense, rises, cools, and then sinks, creating winds. We can see this represented with our surface areas here, and then our atmospheric vortices, so to say, right there. So as this air is heated, it rises and then falls and goes back towards the equator. Okay, so in the cooler regions near the poles, that cold air sinks, moves back towards the equator, is then warmed again, rises again, and the cycle continues. Okay, so these upward and downward movements of air create winds, and the winds will then transport heat from regions of rising warmer air to regions of sinking cooler air. So we can see, in this case, the wind coming off the Sahara Desert towards the equator, where it's picked up and then transported back towards the poles, drops again, and the cycle continues over and over and over. So Earth's rotation causes winds to blow generally from west to east over the temperate zone. So that's us right here. This is why most of our weather moves from west to east, and then east to west over the tropics and the poles. And now the last thing that we have is going to be our ocean currents. Okay, so surface water is going to be pushed by winds that are on Earth's surface. Okay, so again, we see this general east to west right here. Then we see it turning from east to west to east, and then turning again from west to east to west of our surface currents. And they can transport enormous amounts of heat. So up here in Anchorage, Alaska, right here, we have the North Pacific Current right here, this circular current. And it is actually pretty mild up here considering how far north they are, because they have quite a bit of heat that is transported by that surface current, bringing some warmer air to that region. So these warm surface currents add moisture to the atmosphere as well, allowing for differences in climate. Okay, now these deep ocean currents, they were caused by cold water near the poles that sink, flowing along the ocean floor. This water rises in warmer regions towards the equator through upwelling. At that point, it will transfer to our surface currents and help to transport heat. If you have any questions, post them in the comments below, or you can send an email to mr.tucker.schs@gmail.com.